So from prototype to platform, scaling from 1 to 100 plus agents. About me, why should you listen to me? Been spending a lot of time in AI for the last 15 plus years. That includes stints at Microsoft, helping to launch their assistant, Amazon, PyTorch at Meta, starting a small startup. And then most recently, I was working on agents for Datadog, building out the Bits AI agents and helping launch those. And that's exactly where a lot of these new ideas kind of came from. So now I'm working on experimental AI products that think about where are agents going next, not just what are they doing well today. I'll go through a variety of things here. Don't worry, I won't spend a ton of time on each of them. Most of you know Datadog. I hope you know where we're based at least. Our goal really is unified observability. We cover a variety of things in a single pane of glass. But as this intelligence age kind of entered, we started to think a lot more about what does it mean not just to help DevSecOps get observability into their platform, but help automate across the board. And that's where teams like mine came into play, thinking a lot about what does it mean to do AI agents for Datadog, to have Datadog for AI and for AI agents, and then really to build out the next kind of SaaS platform, really the next AI agent platform and infrastructure. What does AI for Datadog mean? These are the agents that we're talking about here: Bits AI SRE, Bits AI Dev Agent, Bits AI Security Analyst, an MCP server that hopefully a few of you have signed up to try out and give us feedback, and Bits AI Assistant, our chat assistant. We're also looking a lot at what does it mean to give observability into these agents through things like LM observability, data observability, all across the board. So the SRE, and important to understand the 3 agents I was spending a lot of time on for the last year and a half, 2 years, because this is where a lot of the learnings came from. The Bits AI SRE is really there to help automate and augment your DevOps, your SRE kind of problems. Incident goes off, go and use a model in a loop, an agent to go and have a bunch of tools to figure out what's going on. Hopefully to do it before you even get to your computer. And then the dev agent thinks about if we see errors flowing through your system, if we see areas we can improve, it'll automatically write code for you so that you don't have to do this yourself. Even though we all have Claude on our desktops or Codex or a variety of other things, you might want something to automatically be running around fixing things for you so you don't even have to think about it. And then the security analyst thinks about this from a security point of view, as you'd guess from the name. What does it really mean, not just to write code to fix problems, but to figure out quickly if a security signal that's coming through is a real one we're spending time on or not. And this is a lot about automating things that human security analysts used to do. And with that in mind, one of the reasons why these start to work is that we've had a huge improvement over the last year plus on the ability for models and the agents that use them to be able to work on long horizon tasks. You really couldn't solve a lot of these problems or start to think about the problems that each of you might be trying to solve at your companies if it was only able to handle context that mattered for one turn, a 5-minute task, a 10-minute task, et cetera. And I don't expect this to slow down. And then pair that with this shifting Pareto frontier of intelligence and cost. You're going to be able to do more and more every day with cheaper models that are just as smart as they were last year and smarter. So what have we learned? I'm going to talk about code and agent first, being proactive, eval monitoring, and all that fun stuff. So we'll start with code first. There are a lot of no-code build products out there, a lot of no-code agent builders and kind of tools out there. I think they're really cool, but as we know, coding is becoming the thing that is easier and easier to do, which means your agents are also becoming the thing that they can actually go and write their own code. They can access your APIs, and they should be able to do that in a way that is code first across the board. If any of you were around, a few decades ago, the Bezos API mandate was pretty famous. This is one where why did AWS really take off the way it did? Why do each of these services work quite so well? Is that he had this kind of mandate that was, look, you need to use these services through their APIs, even within our own company, so you're dog fooding appropriately. So you're not trying to get around APIs. You're doing the thing that our customers will be doing. And there's a shift, in my point of view, that please try to reuse the name. It's the Diamond Agents mandate. This is that all teams will henceforth expose their data in agent-friendly interfaces, things like MCP, APIs, etc. You'll notice if you think of agents as customers and you go try to use your own application or your own websites or websites you're familiar with, they don't all do that. And all the things that you might want to do are not always accessible through the API. They're not always accessible through agent-friendly interfaces. So you should be thinking a lot about that for your own products, and we think a lot about that every day now. Teams really should work to complete tasks with agents. That's augmenting yourself internally to the company. I'm being a little bit stronger here than we need to be, but no other form of task completion jobs to be done. Make sure tasks that you can automate online can be done by agents, and that tasks you want your customers to be able to do are accessible in this way. This is really important for UX. As you work with designers and as you think about your own UX, they may think a lot about, like we did a year or two ago, about how do humans use these interfaces, but you really should be pushing them to think not just about humans, but about how do agents use these interfaces. If you're introducing a new feature, it shouldn't just be a nice toggle on your homepage or on your app. It should be accessible through the API. It should be accessible maybe through your MCP servers, all the above. Anyone who doesn't do this will be replaced by agents. Let's see. All right, so really easy to write code first. Go use any coding agent today, and you can do a bunch of things that you don't need help with anymore. But deployment is still really, really hard. We found this even running our own agents. There's a lot of things they can do, but keeping them running, keeping them operating is still complicated. That's a big reason why you see so many failures in the enterprise. And as I said, really think a lot about agents as users. So what makes a lot of these things hard, and what's the infrastructure improvement that we've thought a lot about? One is that your agents are shifting to be background agents, long-running agents. These aren't just going to be reactive agents. These are not just the chat kind of interfaces that you've been playing a lot with over the last year. You want agents who can think for themselves at some level, but run for themselves, let's say, in the background for hours at a time. And that means you need to have things like durable agents. You need to be thinking about using products like Temporal. Great for long-running kind of durable workflow type things, retriability, all that kind of stuff. You need to be thinking about if your agents are running in the background in long-running ways, they probably need to be sandboxed in some way. You don't want them to have access to everything, but you do want to be able to let them run for a while without a human having to look at them. And they need to have storage, file system, all that kind of stuff, so that they can share data between each other, between runs, between all that kind of stuff. And then how do you keep an agent long running in the background and know when it needs to be triggered? Probably by being event-driven. Event-driven for us means an alert goes off, investigation needs to happen, a security event comes through. For you, it's probably something different. There's always all sorts of different tasks. We see lots of custom agents that are triggered off of changes. A new PR gets pushed to GitHub, so you want to run your custom coding agent to do a review. You have a change made to a Confluence page. You want to run an agent that goes and evaluates it and maybe indexes it, throws it into a vector database, whatever it is that you want. And then a little bit dreaded for some people. I know it's not always easy, but eval, offline eval, online eval, and living eval. This means make sure that as you're shipping these agents, you know how you're going to know if they're doing a good job. It's not enough just to get an agent out there into the wild running. You need to know that it's working well. You need to know that you can improve it. It doesn't even need to be working well initially. You just need a baseline. Then you can go from there. I always think about this as kind of like a Maslow's hierarchy. You need to really start at the bottom of the base of this pyramid with your offline eval, just a small amount of data that you know well, it's annotated, even a couple examples work to start this off. And then as you start to get feedback, have online data flowing through the system that you can turn into offline data that's reusable, know a little bit about what it means to instrument your system and replay problems that your agent might have, and make this living. Things will change across your system. Your customers will change. The tasks that you're completing will change. Make sure that you're not just running your analysis on some data that you overfit from a year ago. And then little bonus, agents on agents. You probably can't read this back there. The nice thing is you can build an agent to help you with this. Then the question is like, how do you evaluate that agent? Well, it's a mess. But you can build an eval agent that's really good at pulling samples, understanding what it means to take production traces and turn them into annotated data. Yeah, I always kind of come back to the agent level bidder lesson. If you know the bidder lesson from AI, it's basically bigger models tend to just work better no matter what you do, and more compute, all that kind of stuff. For agents, it's kind of equivalent. Models will keep getting smarter. They're going to keep eating up a lot of the infrastructure around these tools that you're possibly using. And what that means is you need to have very simple agent harnesses. So if you're running your system, your model in a loop with a bunch of tools, make sure you can swap out models anytime you want. New things come out, go try them out, go evaluate them. Be comfortable rewriting your system frequently. There's a lot of things that you will do today that probably won't be needed tomorrow. We spent a lot of time making sure that we had a lot of like hand-coded data pulling processes when in the end, as models got smarter, 6 months later, a year later, you just give a tool to a model and you say, good luck, you'll figure it out. And they tend to figure it out. So who does watch the Watchmen? Some of it's agents. They can kind of learn to do error analysis across your system, all the above. The other is, not that we're at an observability company, but make sure that you have good observability for all your agents. That means you need to know what they're doing. You need to kind of have a full trace through the system to really understand, context that's going into them, variables they're using, choices they're making. So you can go back and learn when something goes wrong. Go do full session analysis. Sorry, getting close. Memory. Because you're swapping models out a lot, because you're swapping agents out, you're always changing them. Make sure you do some sort of memory. Long-term, short-term memory, whatever. Go and look into it if you're not doing it already. And then collaboration. Multiplayer of tomorrow is not the multiplayer of last year. Multiplayer of the time of Figma, et cetera, was a bunch of humans in the same space. Multiplayer of tomorrow, multiplayer of today even, is a bunch of agents and humans in the same space. This is you being able to give feedback to your agent. This is agents being able to send feedback to each other, send information to each other. And for human to human, it's about visibility. I want to see what someone else in my team is doing. I want to learn from them. I want to go and see what's working for them. So I run an experimental products group right now. We're actually trying to encode all these learnings into a product. It's called dispatchagents.ai. I'm looking for feedback. It's a DataDog product that we're experimenting with right now. Not only would I be happy to talk to you about any one of the things that I mentioned here for building your own product, but if you want to try something out that we try to encode all this in one place, go here. And as I said, the future is changing fast. We're going to see a lot of learning on the job, a lot of longer running agents, even multimodal agents. Be comfortable with that change. Be comfortable swapping these things out. Thank you so much. Hope that was helpful.